So factoring polynomials. Up at the top, kind of a quick review of some of the things that we have done already. You always want to look to see if there's a common factor first, but what if there isn't? So for instance, here up top, some of you may be at a point, especially if the numbers are smaller, that you can just whip out, what this is going to be. If not, I have just a couple of reminders. Some of you have gone and done slide and divide on these, and that's fine. Just a reminder again, in case you are forgetting, if I go slide and divide instead of playing with mental math and guess and check, I slide or multiply that 2 down to the end, which would be x squared minus 5x minus 24, because that 2 will literally slide down. Most of you are good on this step. Most of you are even good when it comes to factoring this part. What are two numbers that I could multiply to negative 24 but add up to negative 5? Okay, so negative 8 and 3. But here comes the dilemma. Some of you are stopping at that point. Okay, and it's not just the slide method. If we're going to factor this way, it's slide and divide. So that 2 that I slid down originally now needs to be divided back in. And if my fraction doesn't reduce or simplify, that 2 will slide back to the front. So that's where my 2x plus 3 is coming from. But 8 divided by 2 is 4, and that's where this is coming from, and I can get the answer that way. So mental math, slide and divide, don't care which way you go after it. Okay, either one can get you to the right answer. Number 2, again, depends on how you look at it. Some of you may look at this and say, okay, I'd do that like I did a diamond before. So what multiplies to 25 and adds to 10? 5 and 5, otherwise known as x plus 5 quantity squared, even though, since I have perfect squares in both of these places, I can just ask myself, what do I square to get each part? And keep the sign in the middle. Okay, there's a shortcut, but it's not one that you necessarily have to use if you're more comfortable sticking with 1 or 2 different methods of doing things instead of having a toolbox of like 6 different things. The one we tend to get issues on, though, is number 3. Okay? Most of you are good about seeing that these are perfect squares. And if at this point you don't know that those are perfect squares, that's something we need to be working on. But here comes the dilemma. A lot of you are wanting to look at this and say, okay, so that's 2x, and that's 3, and then, right, and it needs to be plus or minus. Some of you are still wanting to just stick the sign in the middle and call it 2x minus 3 squared. I can't do that. Whenever it's a difference of squares, one's positive, one's negative, or one's plus, one's minus. The top part is, yeah. Top part is review so far. And then our common monomial factor, otherwise known as our golden rule, find out what we need to be able to see what they have in common. What do those two terms have in common? Okay, I can take a 3 and an x out of both of them. And what's that going to leave me with? Okay, 2x, because I need x times x is x squared. And then I heard somebody say it already. 5. Okay, and that's all I can do with that one. So sometimes it may be as simple as taking out a factor. Other times we may have to factor it once or twice even. And that's kind of our review of what we've learned so far with factoring. Now we're going to add something in. Our sum and difference of cubes. Now notice, with squares there's only a difference. If it's minus, I can do it. If it's plus, I can't. Unless I want to get into imaginary numbers. Here I can do it for sum or difference. Okay? I need to know my forms. Okay, this isn't like when we're foiling things out before and I can just do 2 boxes or something. No, you have to know the form. Otherwise, you're not going to get these right. So here's how this works. Let's say my original problem was x cubed plus 8. Whatever I cube to get each part. So I cube x to get x cubed. That makes sense. What do I cube to get 8? 2. If you don't know your cubes up to, let's say, 5 or 6, that's something you're going to want to work on. That's something I'll put on the sheet here before we get done. But just like with knowing your squares up to 10, you need to know these cubes up to at least 5 or 6. So let me show you how this breaks down now. Okay, first term and second term. When I'm going to put this into its factored form, I take my two terms, and I add or subtract based on the sign in the middle. So since this is plus, it'll be x plus 2. Then when I get here, I square my first term, so x squared, minus, here's one thing I gotta watch out, be careful for. These two signs will always be opposites. So if I start with plus, this has to be minus. If, for instance, here I start with minus, the next one has to be plus. Otherwise, it doesn't work out right. So I go minus 2 times x is 2x, and then plus my last term squared. So 2 squared is 4. That's the pattern that we're going to run. Same going on here. I cube 2 to get 8, and x to get x cubed, and I cube 1 to get 1. Kind of a duh moment. So notice, there's my two terms with the sign that's in the middle. That's always going to be my first set of parentheses. And then my second one is squaring my first term. So 2x quantity squared is 4x squared, plus, the opposite sign, 2x times 1 is 2x, and then plus my last term squared. The cool thing about difference in sum of cubes is that they'll always be in their broken down form right away. It's not like you're going to have to factor it twice or take out another factor or do something fancy. We're just going to do it that way. So when I get into all of these, because we're going to mix them together, some of them are going to have 2 terms, some are going to have 3, some are going to go to 4. Just to help out in this next section, we're going to give you kind of a chart to help you remember. Always first factor out any common term, our golden rule of factoring, and then look at the number of terms to figure out what you do. If it's 2 terms, might be a difference of squares, might be a sum or difference of cubes. Just look at the exponent. Yeah. If you could look at it that way, is that it used to be in factored form before, and now you're kind of, instead of multiplying it out, we're going to multiply it out back into the other form. Yeah, it's a way you could actually look at it. 3 terms, we might slide and divide, we might do a diamond. 4 terms, which we'll get into here momentarily, we're going to group. So if we move this up a bit, my first one, I see it's only 2 terms, and I see it's a cube. Okay, so this is going to be a sum of cubes. What do I cube to get each part of this? Okay, x to get x cubed. And then what about the 27? 3. So now I go, okay, those are my 2 terms. So my first set of parentheses is the x and the 3 with the sign that I see in the middle. So x plus 3. And then it goes, and if you need to look in the box to kind of get a review of it, you can. I'm going to square my first term, so x squared, minus, because again, when I'm looking at the boxes up here, I'm doing sum of cubes. So I'm just following this, so minus the product of my 2 terms, so 3 times x is 3x, plus my last term squared, plus 3 squared, which is 9. If I were to box or distribute that out, I would get all the way back to this. Everything else would cancel out. If you're ever not sure, it's one way you can kind of double check. Now I want to make sure we keep doing things with cubes, but take a look at number 2. Is there anything there in common that I could take out of both of those terms? I could take a u squared, thank you, You take a u squared. Can I take anything out of 16 and 250? Even if it's small? 2. Once I take that out, I'm going to take what's left. So what would I need to get my first term back? 8 u cubed. Because 2 times 8 is 16. U squared times u cubed is u to the 5th. I'm adding my exponent. What about for my second term? 125. What's that? Are you sure? Okay. So now that I'm here, I have to look at what's in the parentheses and go, okay, can I factor that? Ooh, perfect cube and perfect cube. So now, I'm going to take the 8u cubed and the 125, and I'm going to see, okay, what do I cube to get each of those? So, what do I cube to get 8u cubed? Okay, 2u. And to get 125? 5. Okay, I'm going to ignore what I pulled out here, just for the time being. So now I'm going to go to work here. I'm like, okay, I know it's 2u and 5. What sign's going to go in the middle? Minus, because it's subtraction. All right. So then, here we go with the pattern again. Square my first term, which means the coefficient and the u. Change the sign, so I started with minus, now it's plus. Multiply my two terms together, so 2u times 5, 10u, and square my last term. 5 squared is 25. And at the very end, I will put my greatest common factor back at the start. And I'm done. So you kind of see the importance of not only looking for a common term, but also in understanding that pattern. Now, it doesn't mean every time you see two terms it's going to be a cube. For instance, number 3. I see a fourth power, which works the same way as a square does. So I look at this, and I'm like, okay, what do I square to get 25? 5. Okay. And I square 6 to get 36. And I know it's plus and minus. What about this x to the 4th, though? X to the 2nd, because 2 plus 2 is 4. Okay? So if it goes up in an exponent, don't let that freak you out. You just adjust to it. Would have been x squared, we do x and x. X to the 4th, we do x squared and x squared. Can I factor either of these? No, I don't see perfect squares. 5 and 6 aren't perfect squares. So that's as far as I can go. Now that won't be the case every time either. Like, hey, why's it got to be so? Why's it got to be like that? So let's bump up a little. I'm going to jump around a little. I'm going to jump over to 5. I really want to hit home on these cubes. All right. What am I going to cube to get my first term? 3x. I cube 1 to get 1. I'm like, all right. What's 3x and 1? I know the sign in the middle is minus because that's what it is in the original. What's my first term going to be in my next set? 9x to the 2nd, because it's 3x squared, the whole quantity. Switch my signs. Started with minus, now I go to plus. Multiply your terms together, the 3x and the 1. So 3x. And that's the reason I write this out here. I don't want to think this is minus 1 and all of a sudden that sign changes. That'd be bad. So that's why I like to write these out and then square my 1. I'm done. It's easy, but only easy if you know the pattern. So then, yeah. No. No, because the pattern always is these two, yep, those two always have to be opposite of each other. It's just whatever sign's in the middle. So like here, I see minus in the middle, it's a difference. Number 1, I saw a plus in the middle at the start, it just makes it a sum. Okay? Any other questions so far? All right. Now, 4 terms. When it says factor by grouping, what we mean is we're going to pair the first 2 terms off. We're going to pair the second 2 terms off. And for each pair, we're going to take out the greatest common factor. So, in my first pair, what's the biggest thing I can take out? X squared. So if I take out an x squared, what am I left with? X minus 2. Now, if I do this right, when I take out my greatest common factor for the next set of parentheses, I'll get this x minus 2 back again. So we'll see how this goes. What do these two have in common? Okay, if we take out a 5, let's look at this for a second. 5 times what's going to get me to negative 5x? Negative x. Now, is that the same as this? No. So what's one little tweak I could make to my factor? If I make this negative, or minus 5, negative 5 times what gets me to negative 5x, plain old x. Negative 5 times what gets me to positive 10? Negative 2. That's what I'm looking for. These should be the same every time. And then to get my answer, I just recopy the set of parentheses, the quantity they have in common, write it once, not twice, and whatever your greatest common factors were, go in your other set of parentheses, and you're done. So you're like, dang, it's big, I take it apart, I put it back together. Yeah. I just stole my greatest common factors and put them together. And actually, we're going to do that same thing here, because I want to look at 7 and 8. These are the ones I want to get some extra practice in on. So for instance, if we're doing 7, again, here I'm off. What do the first 2 terms have in common? X squared. I can't get a number this time, so x squared is good. So what's that leave me with? 2x plus 3. So I needed one more x to get to x cubed, but my second term already has x squared, so I just need the number. So I have a little clue here on how this is going to work. What do these two have in common? Negative 1. Because then I can have a positive 2x and a positive 3. Because when I distribute the negative, I'll get the negative back. So you're like, all right, I kind of see what he's up to here. So 2x plus 3, and x squared minus 1, those are 2 values outside my parentheses. Am I done? Loaded question. You're like, would Hardy ask it if it was done? Probably not. What the heck else can I do? Look at your red set of parentheses. X squared minus 1. Does that fit any of our factoring patterns? 3 up above. They're both squares. You're like, oh crap, we got to break this down again. Okay, x squared minus 1 is a difference of squares. So, I multiply x by itself to get x squared. I multiply 1 by itself to get 1. And since it's a difference, I have a plus and a minus. Like, ooh, you mean sometimes I got to do it twice? Yes. Depending on the problem, sometimes you may have to do it twice. Not every time, but sometimes. It's just something to kind of watch out for. One more time on this, and then I'm going to hit a couple of weird ones. They're like, hard, this isn't weird enough. No. Keep telling yourself when it's 4 terms, I'm just plucking out greatest common factors. What's my greatest common factor with my first 2 terms? Just an x. Sometimes it's something little. 2x plus 5. What about our second pair? 5, I'm with you. 5 times 2 gets me to 10. 5 times 5 gets me to 25. Sweet. Same quantity. And we're good. So again, just kind of follow the mode, and after a while it's going to end up working pretty decently for you. Now, some other twists that may come your way. We're going to go to the back. Now, you may not recognize number 10 right away as a difference in squares, but it is. You're like, well, wait a minute, square, that's the 4th. But again, it's an even 2, 4, 6. It's an even exponent, so squared can still come into play. So let's think about this for a minute. What do I square to get 16? 4. Okay. What would I square to get x to the 4th? X squared. And oh boy, a big kahuna. What do I square to get 625? Now, I wouldn't expect it. 25. Okay? And if you didn't know that, you could always take the square root of 625 on your calculator. I'll ask the question again. Is this done? No. Which one of those breaks down? And only one of them does. Which thing can we do a what of squares if you look at the front? Difference. So the one with minus is the only one that changes. I'd have to pull out an I to do this one. Okay? So when it's squares, you can only break it down if it's minus in the middle. The plus you're going to have to leave alone. So, what do I square to get each of my terms? 2x and 5. And just like with any difference of squares, one's plus and one's minus. But I can't do it with this one. There is no such thing as a sum of squares. Because if you tried to make that 2x plus 5, 2x plus 5, you'd end up with a middle term, which you can't do. It just doesn't work. Because on squares, it's always going to be the difference. It's always the one with the minus. Because if I tried, just to kind of let you see here, if I were to try and break down 4x squared plus 25 into plus and plus, notice what happens. I end up with a plus 20x in the middle. Well, I don't have a plus 20x in the middle here. So I have to say, oops, I can't do this one anymore. The only one I can do is this one where the minuses, if I bump this up over it a little bit, if I FOIL this out, my 10x and minus 10x cancel out, and I'm just left with my first and last term. Okay? So on squares, you can only do the difference. All right? 11. We're just going to knock off this top row, and then I'll just get out of the way. So 11, anything in common? 4x squared. I always want the smallest exponent and the biggest number. So what's that leave me with? 4. All right. You know the next question coming. Yeah, am I done? Of course not. Treat this as though it were x squared minus 5x plus 6. Just do a normal diamond on it. What multiplies to 6 but adds to negative 5. No, that'll give me negative 6. Ah, negative 3 and negative 2. Negative times negative is positive, and negative 3 and negative 2 is negative 5. So what's my first term going to be in each? X squared, because I need x to the x to the 4th. I will ask one more time. Are we done? Yes. These are not perfect squares. 3 is not a perfect square, neither is 2. So since they're not perfect squares, I don't have to worry about that anymore. Only got to keep looking when everything's a perfect square. 16, 25, 36, yep, numbers like that. One last one. Number 12. Anything in common? 2. All right, get that 2 out of there. Am I done? Silly question. I'm not going to let you just take a 2 out of something and be done. Of course not. I have a sum of cubes because we're going to know here soon, if we don't already, that 64 is a perfect cube, not just a square. So we go, okay, what do I cube to get each of those terms? X and, not 8, it's not square, it's cube, 4. Yeah, be careful. Those ones that can be squares or cubes, it can be mighty tempting to use 8 there. So here, I've got x plus 4. And here we go. Square the first term. Change the sign. Multiply my 2 terms together. Square my last term. And put the 2 back. Because I got to figure out what to the 3rd power, because we're dealing with cubes here. What to the 3rd power equals 64? So 4 to the 3rd power is 64. I will let you create a little chart. I will warn you in advance when we get to a quiz on this. You're not being given a chart. If you want to do anything with a chart, you'll have to create it on your quiz once you get it. So it won't be like, here's a card, or here, squares up to 10, cubes up to probably 6, at least 5. You need to know them. At least to be able to recognize them well enough to know that's the direction you have to be going. And if in doubt, you may even have to play on your calculator for a minute and be like, okay, I know 64 is a cube, but I don't know what it is. Start punching numbers in until you find one. So yeah, we wouldn't have to get up to 8 and all that stuff. That's going to start getting a little bit larger when we have to play with. You might occasionally see one for 7 or 6 or something like this. But as long as you know these, that should be something that should work out pretty well for you. So if you have to give yourself a cheat sheet on the start with these, that's okay. But when it comes to be quiz test time, it's got to be up here. Because otherwise, this gets to be way. Not until after break. It'll probably be, when we get back from break, probably Monday, we might even do a quiz preview and then Tuesday quiz. That'll be sometime after break too. Yeah, we're going to go over after break with everything here. So, your job. No, it's still November. So again, this is your task. Whether you choose to